So we're going to blaze through this little test. Now, the Alberta curriculum really goes into a bit more depth and trickier, so some of these I'm going to skip. I'll try and drop as many hints as I can about the test as well. All right? Credit cards, it says, number 1, have 4 groups of 4 digits. The first 4 digits of a credit card issued by a certain bank are always 4, 5, 8, 3. Any digit can be used to complete the other 12 spaces. How many unique credit cards can this bank issue? So it looks like we have and I think it has to be in that order, so that I got one way to pick that. How many spaces are left, Spencer? Any other restrictions? Nope, then I think it would be... Oh, no, not 12 factorial, Mr. Dueck. Because it doesn't say that I can't repeat. It would be... How many spaces, Spencer? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many choices for this first here if I'm choosing digits and there's no restrictions? Then, what's a shorter way to write 12 tens in a row? I think it's going to be 1 times 10 to the 12th b. So your first question is going to be a fundamental counting principle kind of a question. It wasn't a permutation, it wasn't factorial, it was number of choices. You okay? Yeah? Because you were going like this.
Oh, I know.
Okay, we're good? There are 35 desks in a classroom, and how many ways can the teacher configure a seating plan for a class of 30 students? In a seating plan, that would imply order matters, because if you're picked at a different location, you sit in a different location. I think this is going to be from 35 students. This is a permutation. How many kids are we permutating? 30. Which is that right there. Number 4, skip 3. Jake is custom building a new home. He's given the following choices. Determine the number of different ways that Jack can build his new home. What do you think? Yeah, B. This is fundamental counting principle still, right? That many choices, that many choices, that many choices, that many choices, and means multiply. This would be if I was giving you questions on the non-calculator section of your final exam. This could be how I could get some of those on there instead of actually having you evaluate them. Although I would argue that this is really 12 times 10 times 3, and I think that's fair game to expect you to be able to do without a calculator anyhow. Grow up. Mr. and Mrs. Lang, along with their children, or 6 children, are boarding a plane in single file. And how many different ways can the family line up if one parent must be at the front and one parent must be on the back? I think, again, I'm going to draw a blank. How many choices do I have in the front for the first parent? 2 in my family. How many choices for the second parent? 1. How many choices for the first kid? Then, and I would argue it's obvious here that you can't repeat, because if you're lining kids up, once a kid's in line, they don't leave the line and go line up somewhere else, right? I wouldn't have to say to you without repetition. I think it's obvious. Once you pick the kid, they don't go back into the Scrabble bag. Yeah? How many different arrangements can 5 dogs and 7 cats be placed in a row of cages if the dogs and cats must be next to one another? So if we go with our Scrabble grab bag analogy, we have 7 cats. Cat 1, cat 2, cat 3, cat 4, cat 5, cat 6, cat 7. And then the dogs have to be beside each other. Dogs 1 to dog 5. Okay. How many tiles are there in the grab bag grand total? That's how many ways you can mix those up. Does it say the dogs have to be in a certain order, or can the dogs be in any order? Any order? So how many ways can we mix up the dogs? Did it say that the dogs have to be in the front first? No, if they had said that, it wouldn't have been 8. It would have been the dogs got to be in the front one way, and then there's 7 factorial, 5 factorial left over. How did I do this one? If it has 10 terms, what can you tell me about the exponent? What was the exponent if I got 10 terms? 6? What was the exponent if I had 10 terms? 9. So what they're really saying, I think, Holly, is that this must work out to 9. Right? Oh, that's really grade 8 now. How would I solve this? Minus 20 from both sides. Divide by negative 4. There's a nice little twist. You heard me repeat several times. I kept asking you, hey, how many terms are there? How can I test that somehow? Oh, something like that would work. Example 8, simplify. Okay. I hope you can see I'm probably going to break it up like that, Alex, yeah? So first of all, 4 factorial over 2 factorial. Isn't this 4 times 3 times 2 times 1? Isn't this 2 times 1? Shannon, I would argue the 2 and the 1 cancel. This actually just ends up being on the top 4 times 3, or 12. Nuh-uh. Right? By the way, don't write in these. I should have said that. Yeah? Sorry? Okay. Here, what I've told you is we simply ask which one's bigger. Which one is bigger, n minus 1 or n plus 1? So I'm going to start to expand n plus 1. What's one less than n plus 1? N. What's one less than n? Ah, ha, ha. I can stop expanding. I can replace the rest with a factorial. What's the correct answer? A or C? With authority. A, right? Okay. There's going to be some kind of a simplify on the multiple choice like this. I'll be honest, it's a little trickier. It's got n factorials here and n factorials here. So not numbers, it's all factorials. But still break it up in half and just do the top 2 terms and the first 2 terms and the last 2 terms. Easier to deal with. Which of the following is equivalent to 99p98? This is really testing to understand how the formula works. And according to your formula sheet, which I'm sure you have out in front of you because you're all good test writers, or you might just have the inside cover of your workbook open because that's also got all the formulas, I think. Holly, what is NPR? Well, it's National Public Radio. It's a very popular radio station in the U.S. It's like their CBC. No, I mean, what is NPR mathematically? So, based on that logic, Holly, what's 99p98? I'll give you a hint. 99 factorial, all over. More specific, please. Do the arithmetic in your head, please. By the way, what is 1 factorial? Oh, what's the correct answer here? A, B, C, or D? Okay. And again, on your test, Katie, I will progress very similarly in the order that I taught you. So we're on number 9 here. I'm going to not have as many multiple choice as this question does, but now that we're into factorials, now you can start thinking, oh, now that we're into permutations, I bet you the next one is also going to be permutations with repetitions with the same letter more than once. Like, oh, number 10, how many different ways can letters in the words intentional be arranged? Do some letters appear more than once? Oh, okay, then we use this little trick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to be 11 factorial over 2 i's, 3 n's, 2 t's, 1 e, 2 i's already did, 1 o, 1 a, 1 l. It's going to be that, which is what, if you haven't practiced evaluating these, could you right now? Because it's amazing on this test, on the question that I give similar to this, how many kids write the correct expression and circle the wrong answer, and I don't know why? Well, I do know why. It's because they didn't practice on their calculator because they're lazy. Now, because I'm in a rush, of course, and it's a test, and I have some confidence in my abilities, I would go 11 factorial divided by bracket, but I would go 2 times 6 times 2. Did you say it was D, Brett? Yay! Number 11. Ben owns 9 rock CDs and 7 jazz CDs. And how many CDs? That's what we listen to music to. And how many ways can he take 4 rock CDs and 2 jazz CDs on a trip? Does it suggest that there's an order here, or is it just asking whether he takes them on the trip or they're not on the trip? I think this now is a combination. It would also make sense because didn't we do combinations the day after we did permutations with repetitions? So we're following the same order. I think this is actually boys and girls, rock and jazz. How many rock CDs grand total, Amanda? How many rock CDs grand total, Amanda? How many jazz CDs? How many rock CDs is he taking? How many jazz? I would disagree with his taste, but that's okay. What's the equation? Because and means multiply. Can someone crunch that for me? I'm sure it's an answer on there. See? Number 12. Number 12 would be fair game, the last 2 letters being vowels. If I said to you 1, 2, 3, 4, 5, 6, 7, 8, if we were taking all 9 letters, taking only 6 letters, this gets yucky. And I'm not going in that depth. 13. Hey, pathway problems. Is that a regular pathway problem, or is that a Pascal's triangle? This is a regular pathway problem. It is, because there's no overlap between these two. I can treat them both separately. I can go 1 up, 3 right. The first rectangle is 4 letters, 3 R's, and 1 U. Am I going to bother writing the 1 U? No. And the second rectangle is right, 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 up, up. It's 6 letters, 4 rights, 2 ups. Why can I use a shortcut? Because, Katie, they join at a point there's no lines overlapping between these two. If there was any kind of overlap, or if there was some squares missing, then I'd have to go Pascal's. In this case, 4, choose 3, and 6, choose 4. And the reason I can use choose as a shortcut is this happens to be 6 choose 4, because 6 choose 4 is 6 factorial, 4 factorial, 6 minus 4 factorial. Oh, and this is 4 choose 3, because 4 choose 3 is 4 factorial all over 3 factorial, 1 factorial. Committee question. We're forming a 5-teacher committee group. All 3 art teachers must be on the committee. So here what I would do is I would break it up into art teachers and non-art teachers. Remember I taught you, or I showed you, that a horizontal bar means not everyone else. How many art teachers are there grand total? 3. How many other teachers are there grand total? 13. According to A, how many art teachers must I take? 3. How many other teachers must I take? 3 choose 3, which is 1, times 13 choose 2, which I have no idea. I'm kind of leaning towards A. Sorry? 78? I kind of figured that would be. Now compare that with number 15. Why do I look at number 15 and think, hey, that's a permutation? Yeah, if you now you got a position. Chairperson, treasurer are totally different, so it's not in or out. So the two positions, the chairperson, the treasurer, must be filled by math teachers. So here's the chairperson, here's the treasurer. How many choices do I have for the chairperson? Of course the math teacher should be in charge. How many choices do I have for the treasurer? 5. Are there any other restrictions for the rest of this? Does order matter for the rest of this? So it's going to be a choose. How many teachers are we choosing? 3 of them left over. And are there any restrictions? I think it's going to be the remaining 7 plus 4 math teachers still in the pool, plus 3. I think from the remaining 14, choose 3 of them. 6 times 5 times 14, choose 3. D. At least 4 science teachers must be on the committee. What that really means is 4 or 5. If I have 5 science teachers. Yes, I do. So we're going to have in our bucket science teachers, Mr. Dueck, of which there are 7. Science teachers and not science teachers. 7 science teachers, 9 non-science teachers, although some like me would be both, math and science. 7 choose 4, that means from the 9 choose only 1, or 7 choose 5, from the 9 choose 2. I have no idea what the answer is, but we're okay on that. Yeah? Let's keep going. Ooh. Here's an irregular pathway problem. The only way that I can do this is to Pascal it. How can I glance at it and see that it's an irregular? Missing some squares. Who wants to do the pathway? These are fun. Spencer, talk to me. Right? Mm-hmm. What?
Yeah.
You could do better. Trust me. Okay. There's going to be a question. I'm going to give you an irregular pathway, but I'll be honest, it'll be on the written. There's going to be a regular pathway on your multiple choice. Irregular on the written. Which of the following represents the 4th term? Hey, if they want the 4th term, we're going to use term k plus 1 equals n choose k, a to the n minus k, b to the k, where k is equal to, or sorry, let's do n first. Where n is equal to what, Alex, my friend? You are correct. What's k equal to if I want the 4th term? Tis. What's a equal to? 8x cubed. I like this one. I don't mean I like this one. I like this one. It's a nice challenge. And b is a half y. So it's going to end up being 6 choose 3, 8x cubed cubed, 1/2 y cubed. Why can't I do this right away? What's my y going to be? Y to the what? Nah. Maybe. Oh, let's check my x's. X to the what? It's power to a power. So is it 6 or 9? 9. That didn't help. Okay. What's my coefficient going to be? 6, choose 3, and then I'll have an 8 to the third, and I'll have a 1/2 to the third. It's going to end up being 12,880 x to the 9th y cubed. Number 19, evaluate the coefficient of the c to the 5th d term in this. Nice thing is there's no exponents inside the binomial, so I think probably, Shannon, I should be able to spot the pattern reasonably well. Shannon, what's my great big exponent? So it's going to be a to the 8th, a to the 7th. Yeah. You know what? Normally I'd try and do this on my fingers, but I can see it's going to be a to the 6th. I think a to the 5th b cubed is going to be right there, isn't it? Yeah? What term number are we really looking for? What term number? Yes! Holly, you see how I got that okay? I didn't even bother writing the b's. This one was pretty, it kind of stood out. I got it sitting right here. N is 8. K for term 4 is 3. A is equal to 2c. B is equal to negative 5d. So it's going to be 8, choose 3, 2c to the 8 minus 3, or 5th, negative 5d cubed. And all they want is the coefficients, so let's look at the numbers. It's going to be 8, choose 3, a 2 to the 5th, and a negative, oh, brackets when I'm doing exponents, Mr. Dueck, a negative 5 to the 3rd. A. Number 20, what's the constant term? Are there x's on the top and on the bottom in here, Spence? That means somewhere along the way they probably cancel. When? Well, what's my great big exponent? What's n? Well, not after the 8th term, or so not after the 9th term, because there is only 9 terms. Let's start writing out just the x's and see if we can spot the patterns. So, what did you say the exponent was? So it would be a to the 8th, a to the 7th, a to the 6th, and there'd be a b to the 1 and a b squared there. Let's see if from 3 terms, Alex, I can spot the pattern. I think I can. Because it's going to be an x to the 8th, because that's what a is. Here I'm going to have an x to the 7th, and then a 1 over x cubed to the 1. Here I'm going to have an x to the 6th and a 1 over x cubed squared. How many x's here? How many here? 7 on top, 3 on the bottom, 4. How many here? 6 on top, 6 on... Oh! I don't even need to go to my counting on my fingers. I've already found the 3rd term is when the x's cancel. Yeah. Because I don't care about the 5 yet. I'm just trying to figure out what term location it is. I'll deal with any other coefficients later, but I just know the x's on the bottom. I'll put a 5 there, simplest case, just to follow the x's through. Can you see with the exponents, clearly it's the 3rd term where the x's cancel? Which term? Which term? The 3rd. Which term? Which term? Ah, I can use this puppy again. N, 8, choose. If I want the 3rd term, Brett, what do I want k to be? 2. A to the n minus k. B, now I'll include the 5 because now I'm at my final answer, to the k. Looks like I'm going to get 8, choose 2, times 5 to the 3rd. That's my coefficient. How many x's on top? How many on the bottom? I wrote this wrong. It's not a 3, Mr. Dueck, it's a 2 right there. Which means it's not a 3, Mr. Dueck. It's a 2 right there. Let's try that again. There's my coefficient. 6x's, 6x's. It is the constant term. Did you see why I ignored the 5 temporarily? It was just to figure out when the x's canceled, and then I brought it back to find the actual term. Yeah? I like number 21. I like number 21, number 21, number 21. It's going to be some kind of algebraic solve, choose type question. Holly, what did you say NP2 was? Stop. All over. Yeah. But this is NP2, not n minus r, n minus... Oh, let's plug it in. Yep. N minus 2 factorial. That equals 132. Holly, can I just cancel out the exclamation marks? No, no, I say, no, no. I simply ask, well, first I would get all my numbers to this side, like we did if it was a choose question. We had a number there, we multiplied it over like on today's quiz. Otherwise, I have all my factorials on the same side. I ask, which one's larger? What's larger, n or n minus 2? I agree. Start to expand it. Stop when your term appears that you want to cancel out in the denominator. I get n times n minus 1 equals 132. I get n squared minus n minus 132 equals 0. You gonna make it? Okay, yeah. What kind of an equation is it? Quadratic. How do I know? It's got a square. Make it equal to 0? Already did. Will it factor? Are the numbers that multiply to negative 132 and add to negative 11? I think 11. And add to negative 1. I think I said negative 1. Add to negative 1. Yeah, 11 and 12. In fact, I think I want to go n minus 12, n plus 1 equals 0, plus 11. Okay. 22 is overkill. 23, pathway. Woohoo! Spencer, you awed Amanda so much last time. You want to step up to the plate again? Just hang on. Let's see here. So here we go, Spencer. You ready? Ready? What goes here? What goes here? I can't fill this one in yet because that's blank, so let's fill this one in next. I guess the next one I'd fill in is this one here. Nicely done. People at home are going to be going, what the heck is that? Uh-huh. Quit. There you go. Come on, sit. Ah. I think I started it going again. Oh yeah, we're live, mister. That was for posterity. And with the number of kids that are watching me on Facebook all across the province, kids are going to be wondering who this Spencer is who has a complex. I'm so tempted to say your last name, but I won't. All my kids know anyways, right? Card question. Cards are dealt from a standard deck of playing cards. How many 6-card hands could have at most 4 spades? What does at most 4 spades mean? What are the cases? 4 or 3 or 0. That's too much. You know what? Let's go at most 2 spades, just to make it easier. Which is going to be, and let's draw my bucket. We have spades and others. How many spades are there in the deck? I'm going to actually expect you to know this, so yeah. How many others? 39, yes? Okay, we're picking 6 cards. So for the first one, 13 spades, choose 2. From the remaining 39, choose how many? 4. Or 13 cards, choose 1. 39, choose 5. Or 13 cards, choose no spades. 39, choose 6. Then type it in. Okay. And the last one, which I think will also be the last question on your test, something like this. One of the terms in the expansion of this thing to the 7th power is that. Find p if p is positive. I'm willing to bet this time it's going to be a square root or a 4th root or a 6th root, which technically means plus or minus. That's why they said p is positive, assuming it's the plus answer. Okay. What I really need to do is figure out what term number this is. To do that, I'm going to, Brett, ignore the 2 temporarily. I'm really going to target this m to the 5th. When does that appear? What's my exponent to begin with? So it would be a to the 7th, a to the 6th, b, a to the 5th, b squared. And you know what? If that's a, I think my m to the 5th would show up on that term, would it not? What term number is that? Term number 3. Where n, Brett, is 7, yes. A is 2m. B is the letter P. And K, if I want term 3, what's K? 2. Let's plug in everything that we can here. It's going to be 7, choose 2. 2m to the 7 minus 2 to the 5th. P to the 2. Oh, and I know what that equals. Apparently that equals 24192 m to the 5th over 25. Let's tidy this up a little bit. 7, choose 2 is 21. This is 21. 2 to the 5th is 32. M to the 5th, p squared. 24192 m to the 5th all over 25. How do I get the p by itself, Shannon? Divide by both of those, which it's going to look ugly. I'm not going to freak out, though. I think p squared is going to end up with a 24192 on the top, and on the bottom there's going to be a 25, a 21, and a 32. P squared is going to end up being 21 times, oh, clear. What is on the bottom? 25 times 21 times 32, 16,800. 24192 all over 16. B squared, or P squared, is 1.44. How do I get rid of a squared? Oh. It's got to be 1.2. I'm pretty sure, because 12 squared is 144, so I think 1.2 squared is 1.44. Could also be negative 1.2. Oh, no, they said p positive. Okay. Is that all right so far? Any questions you would like me to do that you've looked at from the review or other weird stuff? Now is your chance to ask. Otherwise, that's pretty much the whole unit and pretty much the whole test for the most part. Anything from this thing at all? Just a reminder, the answer key is online at home. So just a reminder, click, click, under both block A and block B. Combinatorics. Combinatorics review answers. There it is. Can I do number 10? Is that what you asked? You want to print out of this or not? You guys are good? Okay. Is number 10 the... Yeah, you know what? Number 10, I just wrote them out. There's probably a shorter way to get there, but I said, you know what? Linda could win both in a row. Sam could win both in a row. Linda wins, loses, and then wins. Linda wins, then loses both. Sam wins, loses, and wins. Sam wins, Linda wins both. I said, oh, there's 6 possible ways. And then afterwards I went, oh, I could probably have gone how many ways to win 2 in a row, how many ways to split the series, and multiplied. Because I said there's 2 ways to win 2 in a row, maybe there's 3 ways to, I don't know. Is the answer 8? I don't think so. What's the answer sheet say? The answer 6. Sorry? Winning 2 straight. Each of them wins, loses, wins. That's those 2. Each of them loses and then wins both. I think that's every possibility. I'm not a big fan of that question. To me, that was like, okay, I'll just make a list. Again, there's probably a shortcut. I'm guessing the shortcut is 3 times 2, but I can't quite see it yet. Okay. Number 11. So how many 6-digit numbers greater than 800,000? I said if it's bigger than 800,000, my only choice is it's got to be bigger than 8. It's got to be from those digits there, it's got to be an 8 there. Okay. How many digits are left? 5 factorial with 3 5s and 2 1s. That's how many ways you can mix up these remaining ones. It's a word, right? With 2 letters and 3 letters. This was also a surprisingly tricky one. I don't think I'm going to throw one quite that yucky on your test. By the way, you'll notice for number 13, if you look up, if they give you a question on the multiple choice section, don't bother solving this. Just try the 4 answers on your calculator, because I just went 2p2, enter, no. Second function, enter, change the 2 to a 6, no. Change the 6 to a 7. Ah, there it is! You do need to know how to solve that by hand, but Katie, let's be intelligent, clever test writers and save time wherever possible, right? 14 is yucky. Number 10, I didn't go 1 over 8. Talking number 11? Talking number 11? It's not 1 over 8. I said I have to, if I want to be greater than 800, there has to be, I drew a blank. That's a blank. The first number has to be an 8. How many ways are there to pick an 8? 1. Oh, and then there's 5 letters left. 3 of which repeat and 2 of which repeat. And, okay, let's mix them up. That's the only way I could get that 10 answer. And the answer key I know was correct because I didn't make it up. Someone else did. I'm the king of mistakes, but other teachers aren't. Any other weird ones? Sure. Because fundamental counting principle would say you're making a total of 1, 2, 3 decisions. You're not making 3 decisions. There's 10 people. See the difference? This would be if you had those 3 choices and only you were picking one drink only once. How many choices would you have? 4 times 3 times, I got 4 choices. So that would be if you were picking 1 cola, 1 iced tea, and 1 orange juice. This is saying how many ways can I split, how many ways can I mix these up? I said that's the same as saying 4 Cokes, 3 iced teas, and 3 oranges. How many ways to mix it up around 10 people? That's a word. That's really saying how many different ways can I rearrange this? But I'm not going to count you getting Coke 1 as different from you getting Coke 2, which is why I said these are repeating letters, right? Yeah, 14 was tricky. How many different sums of money can be made from the following coins? A penny, a nickel, a dime, a quarter, and a dollar. Why did I write what I wrote here? Oh, it's just how many different sums of money. I said, okay, if I pick 1 coin at a time, there's 5 different ways. I can pick 2 coins at a time, 3 coins at a time, 4 coins at a time, or 5 coins at a time, because they're all different or means add. And each one, I thought about it, I said, oh, each one's going to be a different sum. There was no way, like I thought, well, what if I add a quarter and a nickel? That's 30 cents. There's no other way I can get 30 cents here. Oh, what if I add a dime and nickel? That's 15 cents. There's no other way I can get 15 cents here. I said they pick these coins carefully. No matter what combination you do, you'll never overlap. And again, that's trickier than I'm going to ask on the test. Any others? Sorry, I thought that the review had the answers attached, so I'll email those out as well. Is that it? Holly, we're good? Alex, we're good? We're good? Can you return my little booklets to the box back there?